Hello everyone and welcome back to the next lecture of control systems. In this lecture, we will discuss the open loop systems. In the previous lecture, we discussed the system response characteristics, and in that lecture, at the end, we had discussion on the system configurations. We have two types of system configurations. One is the open loop configuration and the other is the closed loop configuration. And on the basis of system configuration, we have two types of systems. One is the open loop system and the other is the closed loop system. So now in this lecture, we will discuss the open loop systems. So let's get started. We have discussed the block diagram of control system, and we all know that any control system will take an input, it will process the input and it will generate the output. But internally, the control system is divided into two different sections. One is the controller section that controls the amount of input that is required to process the input, and the other is the process section that actually processes the input in order to generate the output. On the left hand side, we have the input to the system, and from now onwards we will call this as the reference input, and on this side we have the output. So now we can say that any control system will take an input, and inside the control system, the controller will control the amount of input that is required for the process, and the controlled input will move on to the process section and it will be processed in the process section in order to generate the output. In this way, we are done with the block diagram of open loop system. Now let's move on to some of the important points of open loop system. An open loop control system is a system in which the control action is totally independent of the output of the system. This point simply says that the input to the system is totally independent of the output. It means that we don't have a feedback signal that tells us how to vary the input, when to increase or decrease the input signal in order to get the desired output. In that case, the accuracy of the system depends on the experience of the user. To understand this, one classical example is immersion water heater. That immersion rod that we put inside the water to heat it. Yes, that one. It goes on heating the water, but it doesn't have a feedback mechanism to tell you how hot the water is and when to stop heating the water. That's why it is a perfect example of an open loop system. One more classic example is of a toaster. The toaster goes on increasing the temperature of the bread, but it doesn't know when to stop heating. And that's why sometimes we get to know that the toast has burnt. So now we are done with the introduction of open loop system. Now let's move on to the advantages of using open loop system. The first advantage of any open loop system is it is simple in construction and design because it does not have a complex mechanism. Also, it is economic because it does not have many elements present in it, and the circuitry is simple. Also, it is convenient to use when the output is difficult to measure. So we have some advantages of using open loop systems, but on the other hand, we also have some disadvantages. And the major disadvantage of using any open loop system is it is poorly equipped to handle disturbance. And as it can't handle disturbance, it is not reliable. So in order to remove the disadvantages of open loop system, we will add one feedback factor from the output side to the input side, and in this way we will move on to the closed loop systems. We will discuss the closed loop systems in the next lecture. As of now, we are done with this lecture. Thank you for watching this lecture. I'll end this lecture here. See you in the next one.